All right, let's talk about similarity. You'll find that this feels very similar to congruency. Congruence. Congruencyitis? I don't know the proper way to say that, but you'll find that similarity and congruence have a lot in common. As we talk about congruence, we're going to review the first part of the explore activities you did. We're going to establish a formal definition of similarity. We're going to talk about why triangle similarity is special. And then we'll talk about how we use triangle similarity all the time. So you got to look at this problem in the Explore activities where you have a 2-foot by 4-foot poster and the larger poster is 6 feet wide. So hopefully you figured out that the poster would need to then be 12 feet long. Now the question is why? Now, there's lots of ways you can figure this out, but you probably found it boiled down to 2 methods. So let's say this is your 2-foot by 4-foot, and this is our 6-foot. And the question is, how long is it? Well, one way you can see it is by saying, hey, to get from 2 feet to 6 feet, I had to multiply by 3. So I'm going to need to do the same to get to here, so it should be 12. We call this the scale factor method. Or in other words, you recognize a scale factor between the smaller and the larger, and you use that to multiply to find the unknown. We could also do this in reverse. We could say I have a 2-foot by 4-foot. If I want it to be half a foot wide, how long would it be? We would do the same thing. Now, the other method that people use is what's called internal factor. This is where we recognize that when we're creating a smaller or larger version of something, not only is there a relationship between the smaller and the larger, internal relationships are maintained. So you may notice that between how wide it is and how long it is, we have this times 2 relationship. Similarly, we could figure out this 12 by saying, okay, if the long is twice what the wide is, then I should multiply that 6 by 2 to get the 12. Either one of these work, and they show up whenever we talk about similarity. You saw something like this when you were playing around with little Johnny's misconception, where we dealt with a poster that's 4 feet wide and 6 feet long. I'm going to mark that on this graph. And Johnny thought that if it was 1 foot wide, it should be 3 feet long. Now, hopefully you saw that was wrong. This is a common misconception. Why? Similarity is multiplicative. In other words, it's a relationship where as one changes, the other changes by the same multiplicative factor. In other words, we have a proportion. So we can say we know that the poster is 4 feet wide and 6 feet long, and this should equal some unknown long by 1 foot. Now, in order for this to be maintained, well, one way I can think of it is I divided by 4. And so I can divide the 6 by 4. And 6 divided by 4 is 1.5. So this should be at the point 1, 1.5. Now, this activity encouraged you to find other similar posters. I guess I should also point out that if we use the internal method, 6 is 3 halves of 4, or 6 times 3 halves, or 4 times 3 halves is 6. So I could do the same thing here. Now let's do some easy similar posters. We could divide it in half, so we could have one that's 2 feet wide and 3 feet long. For some reason this dot disappeared on me. I could do the one that's 8 feet wide and 12 feet long. Heck, I could do stuff like, hey, if it's 6 feet wide, it should be 9 feet long. And you'll notice that that gives us a straight line. You may remember from talking about proportional reasoning in Math 2010 that proportional reasoning is where we first introduce students to straight lines. Because when two quantities are proportional, the graph of different values of those quantities forms a straight line. This will help us form a definition of similarity. I will note that one thing we see in here is the slope, which is over 2 up 3, or the up 3 over 2. My slope is 3 halves, my internal factor.